Hi everyone, I'm Dr. Javier Cifuentes-Faura from Spain. It is an honor to participate in this conference as a keynote speaker. I'm going to present an investigation related to technological innovation, intelligent manufacturing, and ESG outcomes in sustainable companies. As you know, the United Nations 2030 Agenda for Sustainable Development seeks to achieve sustainability through the implementation of 17 Sustainable Development Goals, and the industrial sector is given special considerations in efforts to reduce greenhouse gases and achieve sustainable development. Moreover, industries are also realizing their social responsibilities and potential role in the global sustainable development agenda. Moreover, the environmental, social, and governance (ESG) performance of enterprises has become a crucial measure of corporate sustainability and long-term value creation. Organizations are prioritizing both their financial performance and their environmental, social, and governance practices. For example, the industrial sector in China plays a pivotal role in the country's green transformation, which aims to meet both domestic and international environmental commitments. However, despite growing policy interest, the mechanisms via which digitalization, particularly in the form of intelligent manufacturing (IM), affect corporate sustainability performance remain underexplored. As environmental and social standards tighten globally, there is an urgent need to understand how technological advancements can serve as a lever for firms to meet ESG objectives while maintaining competitiveness. This endeavor aims to address the knowledge gap by empirically investigating how IM influence ESGP through innovation pathways. The aim is to provide evidence crucial for both industrial strategy and sustainable development policy. Further, as the global wave Industry 4.0 sweeps across the world, IM is reshaping the production model and technological innovation (TI) system of enterprises at an unprecedented speed. The IM technology helps enterprises to transform and upgrade with high flexibility, precision, and deep integration of big data and artificial intelligence. Furthermore, IM has significantly enhanced production efficiency and product quality, having a deep impact on companies' TI and market competition. This transition involves a journey from automated production lines to smart factories and from digital design to personalized customization. It also helps shape highly effective smart factories which increase yield and considerably minimize human error. Companies had to improve their fundamental competitiveness by means of TI if they are to survive in the face of fast-evolving markets needs and more intense global competition. IM has opened up new paths for corporate TI by providing advanced manufacturing technologies and solutions. It prompts enterprises to undertake intelligent upgrades in various forms, such as product design, process optimization, production management, and quality control. This accelerates the new product development cycle, reduces innovation costs, and improves the success rate of TI. At the same time, IM has also promoted the integration across various disciplines and fields. IM encouraged the use of new technologies and strategies, as well as new procedures and resources, and injected new vitality into corporate TI. This approach is theoretically grounded in the resource-based view, which posits that firms can achieve a persistent edge over others through the accumulation of valuable, rare inimitable and non-substitutable resources such as innovation and technological capacity. IM enhances these internal capabilities by integrating advancing technologies that promote innovation-led improvement in ESGP, environmental, social, and governance progress. Additionally, the stakeholder theory suggests that firms are increasingly responding to societal and environmental expectations from stakeholders, including investors, regulators, and consumers. Consequently, they align technological transformation with ESG objectives. This study, elaborated with different colleagues from China, aims to examine the influence of IM on ESGP, employing data from Asia-listed businesses from 2012 to 2023. This study intends to investigate the mechanism and pathway through which IM affects enterprise TI. This work focuses on the two dimensions of innovation, TI input and TI output. It explores how IM can promote the improvement of ESG performance and analyze its specific role in improving innovation efficiency, expanding innovation areas, and optimizing the allocation of innovation resources. This study also investigates the varied performance of TI of several businesses following the adoption of IM and underlying causes of this variation. This research is also intended to reveal the intrinsic connection between IM and enterprise TI, offering theoretical backing and practical direction for enterprises to achieve continuous upgrading of TI in the context of IM. This endeavor is significant as it provides empirical insights into how IM enhances ESGP through the dual channels of TI input and output. Mostly, previous research considers innovation or ESG outcomes in isolation. However, the current endeavor develops and examines a comprehensive mechanisms model linking IM innovation activity and ESG performance using a large-scale quasi-experimental panel design. This study contributes a novel framework for understanding how IM drives sustainable transformation in enterprises, offering valuable implications for field strategy and public policy. It is generally believed that IM has a positive impact on ESGP with respect to environmental considerations. IM helps improve the production efficiency of enterprises and also significantly improves their environmental performance by controlling production processes and reducing energy consumption. The implementation of intelligent technology and systems enables companies to monitor and modify production processes in real time, minimize resource waste, and enhance the ESG performance. IM has played a positive role in fulfilling social responsibilities. It focuses on ensuring employee health by implementing additional safety measures. Furthermore, IM also has a significant impact on ESGP in terms of optimizing governance structures. It promotes transparency and sharing of internal enterprise information, enhances employees' sense of participation and belonging, and helps build a more harmonious and efficient internal enterprise environment. So in summary, IM has significantly enhanced the ESGP through its positive impact on ecological sustainability, social sustainability, and institutional refinement. It has advocated for the integrated necessity of sustainable development and social responsibility. This research posits the subsequent hypothesis. First hypothesis of this work is intelligent manufacturing can improve the ESG performance. In terms of environmental protection, IM has effectively reduced energy consumption and emissions in production activities and encouraged better utilization through the implementation of TI. The application of patented technologies in energy conservation is significantly reducing environmental pollution, thereby significantly improving the ESGP in environmental performance. At the social and governance level, IM not only improves employees' working conditions and quality of life, but also promotes harmonious interaction between enterprises and stakeholders, such as communities and government agencies. Simultaneously, the leap in production efficiency and cost savings brought about by IM has created greater social and economic value for enterprises, enhancing their market influence. So the second hypothesis of this work can be stated as hypothesis number two: with other conditions remaining unchanged, intelligent manufacturing improved the ESG performance by enhancing technological innovation output. And with the unceasing growth of TII, the recognition and implementation of ESG have also increased significantly. The implementation of outcomes and improved competitiveness generated by TI not only fortifies the firm's market position but also enriches the firm's comprehension and execution of sustainable production, encompassing social responsibility. This internal driving mechanism encourages companies to pay more attention to the synergy between TII and ESGP while pursuing efficient operation of IM. Consequently, the third hypothesis is stated as follows. Hypothesis number three: with other conditions remaining unchanged, intelligent manufacturing enhances the ESGP by increasing investment in technological innovation. This research pertains to the IM and Application Enterprise pilot project initiated in 2015, characterized as a natural experiment with the objective of assessing its influence on the enduring development of enterprises. This work selected all A-share listed companies in China from 2012 to 2023 as a sample. The purpose is to ensure that the observation period before and after the policy implementation remains balanced. This study employed various data sources to ensure the precision of the information. The ESGP data is sourced from the WASHEN ESG rating, which is connected to the Wine Financial Information Terminal. The database offers a comprehensive evaluation of the sustainable practice employed by the enterprises. Considering the representative of the sample, the study implemented a series of strict screening steps, that is, eliminating companies that were subject to special treatment, the listing risk warnings, and those with suspended listings. These companies often face financial distress or market anomalies that may interfere with the accuracy of the research results. So they propose to validate the outcome with robustness checks. So following the refining data cleaning and sorting process, the study identified a sample set of 4,377 companies. And here you can see on the screen the details regarding the variables employed. Intelligent manufacturing, DID, is taken as an explanatory variable in the study. This work employs the cross product of the dummy variable treat, representing the pilot enterprise, and the dummy variable pose, which represents the period before and after the pilot, to measure the level of intelligent manufacturing (DID). Among them, treat is a virtual variable for digitalizing the supply chain. The value is 1 if the firm is classified as a pilot enterprise for innovation in the supply chain application, otherwise it is 0. Post is a binary variable indicating the period following supply chain digitization. 2015 is a sample year and later the value is 1, otherwise it is 0. Moreover, the ESGP is an explained variable. The current mainstream domestic ESG rating data from SSI's ESG selected. The study allocates values from 1 to 9 for rating C to AAA. Correspondingly, if the corporation receives a AAA, a 3A, AAA rating that year, the ESGP number is 9. Furthermore, this study uses enterprise TII and TIO as intermediary variables, in which the logarithm of the number of patent applications measures TIO of the enterprises. So you can see the name of the variable and the symbol and the definition on the screen. Explanatory variables treat post DID, explain variables ESGP, mediating variables technological innovation input and investment TIO and TIE, and control variables enterprise scale, debt to asset ratio, net profit margin of total assets to jobs in 1 year of company establishment, cash flow ratio, number of directors, shareholding ratio of directors, years, and company code. This study employs a double difference paradigm utilizing the pilot initiatives of IM and application firms as a quasi-natural experiment. This exogenous shock can be employed via the difference-in-difference DID technique to identify causal linkage by comparing the changes in the treatment and control groups before and after the policy was implemented. Also, DID can circumvent the issue of endogeneity that emerged from sample cell selection. The model setting is shown in these 5 equations as you can see on the screen. This table provides an extensive overview of the descriptive statistics for the key variables. Specifically, the average value of ESGP reached 4.132 and its dispersion was quantified by the standard deviation of 1.035. This data indicates that while the general performance of enterprises in China regarding ESGP has reached a certain standard, there remains significant potential for enhancement. At the same time, the significant difference reflected by the standard deviation highlights the uneven development of ESGP. That is, some companies perform well, while others require strengthening, resulting in an unbalanced and suboptimal situation. This table presents the results of the benchmark regression using Model 1. Column 1 does not include any control variables or temporal or individual basic two-way fixed effects. Column 2, on the other hand, still does not include control variables despite having two-way fixed effects. Column 3 does not account for time-specific fixed effects, but it does include control variables. Column 4 contains the variable that will be used to control for any two-way fixed effects. The results show that all the DID parameters are positive, indicating that IM enhances the ESGP and supports the hypothesis number 1. It is evident also from this figure that when using pre-1 as the base period, the estimated coefficient for earlier pre-treatment periods, pre-2, pre-3, pre-4, are statistically insignificant. This suggests that prior to the policy, there were no discernible differences between the treatment and control groups. Therefore, this aligns with the DID model's parallel trends assumption. It is also evident that after the policy implementation, regression coefficients increased significantly, with a more pronounced upward trend over time. This confirms that the policy implementation has a positive influence on the key variables. The placebo test, a robustness test, we designed and implemented was intended to eliminate the possibility that other accidental factors might interfere with the conclusion of this work on the impact of IM or ESGP. During the testing phase, dummy variables for the pseudo-experimental group and pseudo-policy shock were produced randomly. Similarly, the research repeated sampling and regression simulation of these dummy variables 500 times based on the benchmark model. So this figure shows the results in this regard. The estimated coefficient produced by the random process method are predominantly clustered around 0. The randomly produced estimated coefficient markedly deviates from the standard regression value of 0.42, indicating that unobserved random factors exert minimal influence on ESGP. Therefore, it can be concluded that the multi-period double different model set in this article has effectively passed the placebo test, and its conclusion about the positive influence of IM on ESGP is robust and reliable. The current study controls for industry fixed effects as well as the interaction fixed effects of province and year and industry and year, because IM is influenced by industry competition and the regional microeconomic climate. This is to avoid the limitation of the method, which cannot account for all industry and macro factors. So the regression results controlling for higher order fixed effects are present in the table. Column 1 shows regression outcomes after adding industry fixed effects, column 2 after adding industry time fixed effects, 3 after adding province time fixed effects, and column 4 after adding industry time and province time fixed effects. The outcomes indicate that the regression coefficient of DID on ESG is consistently and significantly positive. This outcome further verifies the robustness of the main findings of this work. So now we go with the main conclusion of this work. The current study investigates the impact of IM on ESGP by employing a quasi-natural experimental design using panel data from Chinese films spanning the period from 2012 to 2023. This study employed the DID method along with robustness check. The aim is to provide credible empirical evidence supporting the role of digitalization in promoting sustainable corporate behavior. By focusing on IM, a key element in China's industrial promotion agenda, the research makes a contribution to the literature on ESG. The empirical results confirm that IM has a significant impact on ESGP. This positive effect remains robust across multiple model specifications and placebo tests. Mechanism analysis discloses that TI plays a central mediating role in these relationships. Firms engaged in IM exhibit higher investment and increased patent output, suggesting that technological upgrading fosters more responsible environmental and social practices while strengthening corporate governance. And some policy implications, for example, the promotion of IM should be a central pillar in national strategies to achieve industrial competitiveness, sustainable development, and it's also recommended that regional governments develop localized digital manufacturing clusters and public-private innovation hubs for facilitate the adoption of IM. And regulatory agencies should also update ESGP performance disclosure standards to include different metrics that capture innovation drives changes in business behavior. So this is the end of the presentation of this work elaborated with different colleagues from China. Thank you so much for your attention. Hope you enjoy a lot. Thank you.